Hey, section 202. So, because I ran over time a little bit today, I mentioned I would be sending a little recording of the 8-ball problem. And so that's what we're going to work on right now. So, what is the 8-ball problem? Well, the 8-ball follows in the great tradition, the grand tradition of all future telling people, all astrologers and any fortune teller is going to pick an ambiguous statement so that based on events which happen to you in real life, you're going to feel like they were foretold by said fortune teller. So how do we actually deal with this in Python? Well, let's break the problem down. So there are some classic 8-ball examples, which are given here, the first 20, right? However, I'm not going to read them all out. Instead, we're going to take a look at the sample run. So the sample run says that we should execute the code Python 8-ball, and we should be getting a yes/no question, right? And based on that, we should get a solution, right? So the milestone which is given, this question sort of breaks down naturally into two parts. One is to simulate the smaller problem of getting an answer to one question. And then we generalize that same concept to how a real 8-ball works. If I had a real 8-ball at hand, then I would shake it once, see something, shake it twice, see something else, and then put it away, right? That's not an 8-ball, that's my coffee cup. But yeah, okay, so let's try and see how we break this problem down. Now, before that, there is a little bit of sort of foretelling of what we need, and that is the import random library. You may have seen this already in your lecture, but we'll discuss how this works. So conceptually, quick word about what we covered in section today. Conceptually, what we're going to think about is, once again, in terms of our favorite Python box, right? Only this time, we're interested in libraries. So what makes a library? So we've seen how we've discussed how we can work with the Python space, right? And within that Python space, we have different function scopes, as it were, different boxes for different functions, like me. Now, what a library does is that you can imagine it as a sort of series of functions. So a library brings with it a whole bunch of functions. So really, the only consideration which we need right now, I'm so sorry, I just realized I wasn't showing the right screen. So the consideration which we need to have, let's try this again, is within this Python box, just like we have global variables, just like we have functions as we discussed today, each of which are in their own little boxes, if you will. If I wanted to use a whole set of functions, then I could import that as a library. And just like we recognize that when you call a function, then it expands into its definition. When you run the import command, import a library, then you bring into scope, which is to say you can imagine bringing a box full of many functions which are defined in this library. Okay. So practically speaking, there is a distinction which happens here, which is when you want to use a function from that library, then you need to prefix it with the name of the library. Later, we'll see how to extend the import syntax, but for now, let's keep it like that, okay? So if I want to call function randint, which is random integer, then, sorry about that. So if I want to call random integer, then I will need to first say that I want random integer coming from random. So I would put random, then the dot, and rand integer. Now, notice that similar to our standard definition, a standard understanding of functions, rand int is a perfectly valid function. Why? Because it takes an input, in this case, 2 inputs, and returns an output. So in particular, random integer takes 2 numbers, which is the lower range and the higher range, and returns an integer from between that range. What does this mean? It means if you imagine the number line of all the integers, if I want a random integer from here to here, then that's exactly what randint will give us. Let's see how that works in practice. Now, notice that it is going to be inclusive, but actually, talk is cheap. Let us try. We're going to be running this in the interactive Python terminal, which we discussed a little bit today. The reason is we would like to see. So we could also just read it off of the description, but rather than do that, it's always better, or it's nicer to play around. And we see that we're getting random integers, but already we can see that we've hit 1. We saw 1 at least one time. Yeah. Now I could keep doing this, but and I got a 4. So clearly we get a random number which is inclusive of this and this. Mathematically, for those of you who are interested in that sort of stuff, this would be x is an element from between, which lies between close bracket 1 and close bracket 4, and x is an element of the integers. If you'd like to define a set of integers with the alphabet capital I, right? Okay, so how does that help us at all? Well, remember, the 8-ball can't actually tell you the future, right? So, sadly, there is no way to program prescience into our Python program, right? Instead, what we want to do is we want to shake our 8-ball, we want to run our 8-ball program and see an output. So let's try to break this down in the same manner which we broke down the previous question. Okay, now, once again, just like we did in the last question, let's see, what do we see? There is a print statement, right? So this is a print statement which we will need to write. And this is coming from some sort of user input. In what kind of user input? Well, if you remember, the input function would return string, but okay, we're getting ahead of ourselves. And we get an output. Now the output, to get this output here, right? The red boxes. In order to get that, we do need to do a calculation. And what calculation is that? Well, it's a random draw. So here's a trick question. Given that we have the system, right? We have a programming language and we have random integer. What is truly random here? Like, so we want to choose, we want to get back a randomized response, yes. And we've seen that the rand int function does that for us. So for now, we'll skip the question of how random is that random number really, but I'm happy to take more questions about that later. A quick spoiler though, in case you're interested, these are pseudo-random numbers, not truly random numbers, because they depend on something which we will see later in the lectures. Yeah. Okay. So to get back to our problem, we have now decomposed our problem into, we're reusing the same function, the same notepad which we were using before. To solve 8-ball, we need to solve the smaller problem first. One question and one answer. So the one question and one answer problem is we would like to print a prompt, take a question, return an answer. A key thing to notice is these two are independent. So why am I saying that? Like, that may not be the first thing which comes to mind, but the question which you get is completely independent of the answer which is returned. Okay. So what does that mean? Let's start writing out the scaffolding for this. Let's start by the print statements, what we know how to do. Ask a yes or no question. Okay, so in the same logic, using the same logic which we applied in the previous question, we would possibly not, we would like to store these strings globally. Now, in order to store a global string, we will write it. We will define the global variable on the top. So let's call this K8 all. Okay. And let's go with not a chance. Now, I'm going to quickly fill a couple of these. So it should be understood that the reason why we want to do this is just we're utilizing the same logic which we threshed out previously, which is in the scenario where we might want to reuse a variable in many different functions, right? Then in that situation, it is a good idea to make it a global variable. So that concept is following us from the idea which we had here of falling through of variables. So if we define a global variable, then those variables can fall through. They can exist inside main, they can exist inside any other function which we would like to define throughout this program, right? Okay, so now we have 4. Let's make one more. Something negative, perhaps. Never. All right. So let's see where we're getting right now. Now, something to think about at this stage, maybe pause the video and think, do we need to store this variable here? Remember, the input function, as we discussed, is a special kind of function. Sorry, my bad. The input function is a special kind of function which takes something from the output, from the input, and returns that same thing with one small slight caveat. It's a string. And we saw this and how to deal with this in the previous question, right? When we were solving the Mars weight. Okay. So once you've unpaused the video, then both are equally valid. You could store this, but remember, we don't actually need to have an input when we call random integer. We need a range, and then we can call it. Okay. So at this stage, we would say that we'll wait for the input. We won't assign it to a variable. And then we would like to call 1 out of 5. Yeah. This we do need to assign because we would like to know what that choice was. And why is that? Because now we would like to choose one of these variables to print out, right? We have the choice of printing out either 1, 2, 3, 4, 5, and we would like to print one of them. So in order to do that, what we're going to take a look at is a special kind of operator, logical operator. And it is the equality test, the test for equality test. And we're also going to discuss briefly how it separates itself from the assignment operator. So first thing, clearly, one of them has 2 equal to signs, the other one has only 1 equal to sign. So that's the first difference. This one, the one on the right, is used to assign a variable. What does it mean to assign a variable? If you remember, the assignment of a variable is a very important operation. Looks like this. And what it does for us is it makes a box with that value. Remember, in this case, we're talking about a box and not a label on the box. Once again, a distinction more appropriate for later. Okay? So that's this one sorted out. It makes a box and puts a value inside the box. So we get a box with a value if we were to write X and 34 or 35 or something else. What about this guy? Well, this is part of a conditional. And in fact, the conditional works exactly the same way as it did in Carol. You remember Carol from last week. So we return an answer at random. So that's an important distinction. So once we take a question and we've decided to discard the output actually, sorry, the input, we're not storing it in a variable. Then we say return an answer at random. So we need a random variable and a selection mechanism. Okay. First selection mechanism that we're going to do is if choice is equal to. So the double equal to is the test for equality. The test for equality is decisively not the same as assignment. Here we're saying check if this comes out to be 1. If it is 1, then we would like to print a 8-ball 1, right? And if not, let's quickly put these here. Okay, so let's say am I a good teacher? Random is not defined because we did not do the import. By convention, we should import our libraries right at the top, even before we define our global variables. Okay. How about now? Python. Never. Wow. Okay. And so you feel free to play around with this if you like. That's not a yes no question, so it makes little sense. So did you have lunch? Is a yes no question. Anyway, so this is the first form of the solution. Okay. Now, when I say first form, then you might think, what are the other forms? Once again, please pause the video now and think about other ways to do this. What's missing in this concept here right now? Actually, nothing. We are for now ready with milestone 1. What about the second milestone? Now, if we take inspiration from Carol again, then the inspiration which we can take, first of all, let us do a small refactoring, which we have seen previously, or which we might want to do, which is roll 8 ball. Let's define a function roll 8 ball. And although there's no real reason to make a new function here, it does emphasize the rationale behind making these global variables, similar to what we did in the Mars wave problem. Okay. Okay. So now we have this roll 8 ball function, and we would like this to be executed multiple times. For those of you who were with me last week, you may remember that we have a while loop. And there we had a situation with beepers and we were doing while front is clear, etc., etc. The point of the while loop, though, is it recognizes an end state. So we will recall, for just so we're all on the same page, we recall that for a for loop, it is the number of steps. Now, both loops can be used equivalently in most cases, but this is the more natural way of thinking about it. If I have a starting point, and it's the journey which is important, maybe each step is expensive, maybe each step costs me $500 and I don't have that much money, then we would say, let's use a for loop, because we know how many times we have to or we can make this iteration. If, on the other hand, I know my end state, I don't know how long it will take me to get there, but I know I want to get there, like me and my doctor, then we will use a while loop. Why? Because we say, well, I'll know when I get there. I'll know that I have a doctorate when I actually receive the PhD. In between, anything can happen, it doesn't matter. So this distinction here, right? The end state detection compared to the number of steps you can take concept, yeah? What happens then, and pause the video and think about it, what happens if we have an end state which is never going to come? Or to put it another way, if I were to tell you while true, which is always true, right? So remember, the while loop works on the basis of evaluating a condition, and then as long as that condition is true, the while loop is going to continue. So this is a never-ending problem, hopefully unlike my PhD. Oh, sorry. Now, what does this do, first of all? For one thing, it repeats constantly. Okay. First point. This is happening because we do require the input to happen for each roll of the ball, which is to say, rolling the 8 ball involves asking the question. So what might be a good statement here then? Welcome to the Carol 8 ball. Yeah. Welcome to Carol 8 ball. You can imagine this to be a sort of branded, Carol branded 8 ball, right? And now what we're saying is we're going to rerun this. Let's see. We seem to be fine. This seems to be something which is working. Which actually sort of solves milestone 2, only we have a slight problem, which is that it's never ending. Now, a couple of ways to deal with this, but what fundamental change needs to happen now? Think carefully about the structure of our program until here. If I want to have a condition here, what could that condition be? Now, in case you're wondering, yes, definitely it is perfectly valid for us to perhaps put a for loop here and say, ask 5 questions to Carol, ask 10 questions to Carol, yeah? However, what if? So what is something which we might have, what information are we not using in this code? Like, is there any information which you can think about, which we have, but we're not using? So let's think about this. What are we doing? Multiple rows with the 8 ball. And we said refactor or modularize into a function, call function until. And we said this is a while statement, perhaps, since we have an end state. And a first approximation to our solution is while true, which is always true, yes, and which has the slight problem of never ending. But then if you were getting the future being told to you constantly, why would you want that to end, right? Nevertheless, we would like this to stop at some point. To have a control parameter in this problem, we can make use of the input. Think about this carefully and what it means. What are the ramifications of this? What I'm saying is using the end state, we can actually control the while loop. Now, the very first refactoring which we do in this case is we move it back inside the loop. First thing. The next thing is we use the input to sort of test a condition. Let's say while nothing is entered, you know, let's give that a shot. Okay. So what went wrong? First of all, we read the error message. Local variable end state, blah, blah. Now, there's no need to consider what local variables are at this stage. There is, however, a very fair argument that we've taken the input, sure, but Python works line by line. So it started with printing welcome to Carol 8 Paul. Then it went into the while loop. And before it executes even first line of the while loop, right before that, then it's saying, hey, but this doesn't exist, right? So what can we do? For one thing, the immediate question, the immediate thing which comes to mind perhaps is we can move this up. But what problem will go? What problem can happen here? Without taking any further inputs, what about this? So what we're doing here is we're saying we're defining this here and we're redefining this variable here. Let's see if that works. Let's try this out. I should have put the print statement. Okay. So let's actually refactor this code a little bit more to sort of encode the knowledge of milestone 1. Because as we know from the Carol examples, if you're rewriting the same line multiple times, that's not a good thing. You want to immediately see that and say, maybe a function would have helped me here. So let's call it answer one question, takes nothing, but prompts for an input, and then calls roll equal. Okay. Simplest version. Now, this run is purely to convince ourselves that same thing is going to happen here, right? So we can do a keyboard interrupt, which is Control C, or yeah, it's Control C across all operating systems, right? Okay. Now what we need to do is we want to refactor this code. We want to add in, we want to take cognizance of the input, right? How do we do this? So we would like to think about, or what are the steps to solve this problem? Forget about the actual way we're going to do this. So the concept which we want to do is use the user input as a control variable, right, for the while loop. So if we want to use the variable, then we need to define the variable first. So we require a variable to be defined. Let's actually call a spade a spade. So we will call it question. Now, as we discussed, this is not my favorite form of working with this, but input takes in a string which it displays as well, optionally. I personally prefer print and input, as we have seen in the workspace. Okay, so what does this do? At this stage, we have some string Remember, input returns a string, and that string is sitting in question. Now we can provide a check on the string, yes? And what is the check? Well, perhaps the first thing we could say is maybe while question is not no, or quit or something, then we would want to do answer one question. Now, crucially, we need to get question again here at the end. We need to change this variable. We need to reinitialize this. We need to change the value of question within the loop, because otherwise it only gets asked one time, right? So let's print out this logic. Let's write out this logic, right? What did we decide to say? We said there is a variable question and it takes an input. We are using this form. Although it doesn't matter which form we use. And while the question is not initialized, while the question is not equal to no for now, we would answer the question. Now, in order to answer the question, what we need to do is roll the 8-ball. So effectively, these are one and the same thing. It's important to remember here, the key concept to remember is that the loop ends at the end of this indented block. So long as we reinitialize, as we change the value of question within the loop, then the loop will continue, right? We'll stick with our original roll 8-ball. Let's go for it. All right. So at the moment, it seems to be checking. Okay, so can anyone tell me, perhaps if you're watching the video, then you would have already noticed the problem here. What are we checking for? We're checking to see if it's, so the loop is only true when it is equal to no. What we want is the exact opposite of that. And then. So key takeaways here, debugging or the process. So the process which we went through here was really also about debugging. How do you, and some of the steps that we showed here are going to help you in larger situations than this code. That is the ability to step back from the code, break it down into pseudocode, into its constituent parts, and then go back and deal with syntax in a way with print statements and tests to see what your loop is trying to do, to test everything really. And yeah, if we would like a cleaner approach, we might want to leave a blank string and say if someone is given a blank string, then that means that they're probably done with Carol, with a Carol 8-ball, they're tired of Carol 8-ball. Yeah. And yes, that's all for the 8-ball challenge. That's milestone 1 and milestone 2. And the only reason why we want to use the empty string is because it's specified in milestone 2, basically. All right, so thank you. And I hope I see you next week. And yeah.